Assalamualaikum, this is 981017 Yasir Zahid, and then in this video we will be implementing LAB13, which is synchronous up counter and synchronous down counter using a 4-bit register via JK flip-flop. Now first of all, I will be explaining this up counter. Okay, right here we have shorted all the J and K, and all J and K are given the same inputs or whatever the input is. When we have our J and K shorted, we call it a T flip-flop. For first JK we have it as 1, for second we have it as the output of the first flip-flop, for third we have it as AND of the output and input of second flip-flop, and for our fourth flip-flop we have our J and K as the AND of our input and output of our third flip-flop. This combination reduces the frequency by half, making this the half of the previous, this the 1/4 of the first, and this the 1/8 of the very first. So making this frequency difference enables us to get all the possible combination for our 4 bits. Just like we did in Proteus, we settled our frequency to 50, 100, 200 and 400, so that we get each bit as the 2 times of the previous one, or as half frequency of the previous one. Now I will be simulating this synchronous up counter. Here you can see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and back to 0. So this is going for ABC because this is in hex code. That's the only possible combination on this 4-bit BCD display. We can also change the frequency. If I change the frequency to 2, we'll get a little bit speedy counting like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and that goes down back to 0. And now I'll be explaining the down counter. First I'll explain the down counter, and then I'll move to its simulation. Now here, this down here is the circuit of down counter. It's pretty same to what the up counter is, but the only difference is that the input of the second flip-flop is the Q0 of the first flip-flop, and for third we have it as AND of first and not of output of second, and for fourth we have it as input of the third and the output not output of the third. So previously we were using the direct Q outputs, now we are using Q0 outputs. So this makes the change, and we will be getting the reverse count. Here you can see 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So this is all the reverse count for all these possible 16 combinations. So this was all for this lab. I hope I have explained everything. Thank you and Allah Hafiz.